Hi, and welcome to our first video in our series on logarithms. Now, logarithms are going to be one of the first topics that are 100% entirely new, and they do take a bit of getting your head around. So we're going to go for this first video nice and slow, just so we get a sense of what's going on, and then there's a whole world of stuff that we can do with these things. So here we go. So what we've got to get through is understanding how logarithms and indices, i.e. powers, are linked, and then being able to write statements using indices using logs. And then we've got a whole bunch of things called log laws, and then we get to really useful stuff when it comes to solving equations using logs. So they're incredibly useful, but like I said, they do take a bit of thinking to begin with. So here we go. Right, so we're going to just have a look at kind of what a logarithm is and how we go about rewriting statements involving indices or powers using logarithms. So here we go. There's a statement that's all nice and straightforward. We've got 10 squared is 100, where that thing there is the base, the 10, that's the power, the index, and you end up with the 100, that's the result. And there you go, I've enlisted the help of Homer Simpson on this one. So we're saying 10 to the power of 2 is 100. What we're going to do is take that statement that our pal Homer's come up with and just rewrite that using something called logarithms. So what we're going to do is say we've got log, and we put the base there, so that's log to the base 10 of 100 is 2. So we've got the base there, the result, that's 100, and then that power, kind of that is what we call the logarithm. So as Homer's going to tell us, we've got the log to the base 10 of 100 is 2, and that's what this thing here is telling us. So basically all it is just a different way of rewriting your powers, and when you start looking at how we can kind of play around with powers and how we can use these, it becomes immensely useful. So what we're going to do is just look at two versions of writing the same thing. So on the left we're going to have our version using indices, same as we had in the previous scheme, and on the right we're going to have our version using logarithms. And it might be a good idea while you're doing this, have a bit of pen and paper with you, so when I chuck the one up on the left using indices, if you have a go at writing it as a power, pause it, the video, and then see if you're getting it right. Might be a good way to go about it. So here we go. So 2 to the power 5 is 32. So we're going to say how we're going to use that, write that using logarithms. Well, that is going to be log to the base 2 of 32 is 5. So we're saying 2 to the power 5 is 32. So log to the base 2 of 32 is 5. Here comes another one. 3 to the power 4 is 81. So we're thinking log to what base? What's my base going to be? Well, the base is going to be 3. So it's log to the base 3 of what? 81 is 4. So we get the statement there. Okay, works with negative powers as well. 10 to the power minus 5 is 0.00001. So writing that, so this one is a base 10, so it's going to be log to the base 10 of this thing. So log to the base 10 of that, 0.00001, is going to be minus 5. And let's just turn it around a little bit. So say now this time I've got log to the base 10 of 2 is what? So we're asking ourselves the question, we've got our base, which is 10. This is going to be the end of our result. So the thing that's going to go here is saying 10 to the power of what gives me 2. And if you grab your calculators, you'll find your log button. So you can just type it in, log to the base 10 of what gives me 2. It's going to be that number there, 0.301229, the rest of it. And so what we've got is kind of the index version. We're saying that 10 to the power of that is 2. There it is. And like I say, at this point, might be a good idea. Just kind of pause the video, grab your calculator, do a bit of punch the buttons and numbers, and making sure you're happy with all of that. 2 to the power minus 3 is 1/8, because we know that negative powers is 1 over. So that's going to be, our base is going to be 2. So we've got log to the base 2 of this thing. So we've got log to the base 2 of 1/8 is minus 3. And the last one, square root of 5, so that's 5 to the power half, 2.23606, blah, 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 lots of decimals. So we've got a base, let's have a look at it here. So the base is going to be is going to be a 5, so we've got log to the base 5 of this number is a half. So there we go. So let's say it's just to begin with, just a case of just taking those statements on the left and rewriting them using logarithms on the right. And like I say, you just need to spend just a bit of time just going through those, and once you get the hang of it, they're reasonably straightforward. But like I say, it does take a bit of thinking to begin with. what we're going to do is keep going now, but do it a little bit more algebraically and start thinking about certain values that logs can and can't take. So here we go. There's a statement that we know. A to the power 0 is 1, as in any number whatsoever. Anything to the power 0 is 1. What is that going to be using logs? So we're doing log to the base a of 1 is 0. So we get that statement. And what that means is anytime you've got log 1, the value is always going to be 0. And again, you might want to pause, grab your calculator, type some numbers in. Anytime, doesn't matter what base you use, log of 1 is 0 every single time. There's another fairly obvious statement. A to the power 1 equals a. That looks like that using our logarithm version. And again, what that means this time is if you've got the base and the value the same, as I've got inside my little red circle there, then the value is always going to be 1. Okay, it's at this point when you start doing the entire thing algebraically with no numbers that you start to kind of lose a little bit little track of what's going on, but we've hoped to do enough numerical examples so you're confident you know what's going on with this. So if we're going to write this statement using logarithms, there's our base. So we're going to log to the base a of y is x. So there we go. There's the log version of that one. Now, just a couple of little bits and pieces, just to finish off this section. So if I have log 0, so what is that going to be? Well, let's say again, you might want to pause and have a little think about that. And the answer to that question is that if you take any number at all and raise it to a power, you're never going to get 0 as an answer. So what that means is log 0 simply doesn't exist. Because imagine taking 10 to the power of what equals 0. Doesn't exist. 15 to the power what equals 0. Just simply not possible. So log 0 is undefined or doesn't exist. That's one to watch out for. And can you have the log of a negative number? So for example, if we had a negative here, well again, any number to the power of something is not going to be negative. So a positive number, when we have a positive raised to the power, the answer will negative, so it's not possible to get the log of a negative number. All right, and so that's kind of rattled through very much the basics of logs, and in the next few videos we'll see how we can really extend these ideas and start doing some really useful stuff with them. But for now, it's important you just take the time and make sure you're happy and comfortable just basically rewriting your index statements using logs.